The lesson topic for this video is probability versus odds. Okay, so let's take a look at this situation. There are 5 students who were selected for a chance to win a prize. Anna, Brian, Carson, DeAndre, and Evan. The first question asks, what is the probability that Carson is chosen? If a student is chosen at random, of course. So, how many students are there altogether? There are 5. And how many ways could we choose Carson? 1. So the probability is 1 out of 5. Now, odds is different. You might have used the word probability and odds interchangeably in the past, but notice they are going to be different answers. So odds in favor of Carson being chosen means how many ways are there to choose or get Carson? Well, there's still just 1. But the denominator for odds is not the same as in probability. The denominator for odds in favor is the number of ways to get somebody other than Carson. Well, 1, 2, 3, 4 people are not Carson. So there are 4 ways of getting somebody other than Carson. So the odds in favor of Carson being chosen is 1 to 4. Usually odds are written like this, and we say 1 to 4 with a colon in between, which again we would write 1 or say 1 to 4. So the odds are 1 to 4. For every 1 time Carson would be chosen, there are 4 times he would not be chosen. Again, that's different than probability, because probability is Carson would be chosen 1 out of 5 times. So then what's odds against Carson? Well, odds against Carson is simply going to be the reciprocal of odds in favor of Carson being chosen. So odds against Carson means, okay, let's start with how many ways could we choose Carson? Well, still just 1. That is this time going to go in the denominator. Then how many ways are there to get somebody other than Carson? Well, 4. So we would say 4 over 1 or 4 to 1. So here are the 3 equations for probability and odds. Again, probability of A happening is the number of successes, or the outcomes you're counting, divided by the total number of outcomes in the sample space. Odds in favor of A happening is the number of outcomes you want, and again I say want in quotes because it's not really what you personally want or desire, it's what the question is wanting us to figure out. So like what we would want in the previous example was Carson being chosen. So odds in favor of A is number of outcomes you want divided by the number of outcomes you don't want. So all the other students. Odds against A is again the reciprocal. So if you take this and you do the reciprocal, number of outcomes you don't want over number of outcomes you want. You might want to jot these down in your notes. Okay, so just to revisit the very first slide we were looking at for one more second, I want to point out that whenever we look at an odds answer, you'll notice that since this is the number of ways to get what you want, and this is the number of ways to get what you don't want, if you add these up, what should that number always be? Well, it should be the number of total outcomes in the sample space. All of the list of what you want, all the list of what you don't want, together have to add up to the total number of outcomes. The same thing will happen for odds against, of course, because it's just the reciprocal of odds in favor. Okay, so one more example set. A class has 5 seniors, 15 juniors, and 10 sophomores. You need to choose 1 student. Now I'm going to ask that you try these 5 or 6 actually questions and then check back to see how you did. Okay, so how many outcomes in the sample space? Well, I'm going to choose 1 student out of the total of 30 students that are in the class. The probability of getting a senior, well, there are 5 seniors, so that's the number of successes of getting a senior, divided by the total number of outcomes. So we are talking about 1 out of 6 chances. What's the probability that we're going to get a senior or a junior? Well, you might remember that or is typically going to remind you to add probabilities, because if you think about it, probability of getting a senior or a junior becomes more likely because there are more students that would make it successful. If you want to separate this out and say the probability of a senior is 5 out of 30, and the probability of a junior would be 15 students out of 30, and add them, you will get 20 out of 30. If you also just looked at the list and said, oh, well, 5 seniors, 15 juniors, that's 20 out of 30 without doing this work, that would have been just fine. Now, the probability of getting a senior and a junior. Now, this word and might have made you think that you are going to multiply, but you're not. See, in this case, it's asking you to choose one student. If you think for a minute, what's the probability that if I'm picking one student, that student is a senior and is also a junior? Well, that's 0. There's no chance of that. All right, now odds in favor of a junior. Well, there are 15 juniors, so we start this like probability, but the denominator is not 30. And if you put 30, you have this wrong. Odds in favor of a junior means number of ways to get a junior on the top, and in the denominator, the number of ways to get somebody other than a junior. So that will be 15 as well. Okay, notice there are 15 juniors, and then who in the class is not a junior? Well, 5 seniors and 10 sophomores. So 15 people are not juniors, and 15 people are. This means that we have a 1-to-1, or we could write 1-to-1, odds in favor of choosing a junior. For every one time a junior is chosen, there is one time that a junior is not chosen. The last example, odds against a sophomore. Again, this is one that people make mistakes on sometimes. We have to be careful. So odds against a sophomore means that we're going to put the number of ways to be successful in getting a sophomore in the denominator because it's odds against. So since there are 10 sophomores in the class, we're going to put that in the denominator. And now the numerator is going to be the number of students in the class who are not sophomores. Well, there's 5 seniors, 15 juniors. That's 20 students that are not sophomores. That goes in the numerator. So 20 over 10, or 2-to-1. You can write it like that as well. So for every time not a sophomore is chosen, there's one time that a sophomore would be chosen. I'd like to remind you of one last thing before the video is over, and that is if you look at both of your odds answers, if you add up the numerator and denominator, 15 and 15, you get the total number of outcomes, 30. If you add 20 and 10, you get the total number of outcomes of 30. That will always be the case for odds.